In this video, we're going to evaluate the integral of x to the third over x plus 1 x squared, quantity squared. Now, there's at least two ways to evaluate this integral. The regular or standard u substitution is not going to work here. If you let u equal, say, 1 plus x squared, the derivative is 2x. We have an x cubed there, so that's not going to work. You can use a trig substitution. I'll probably come back and work this out using a trig substitution, using the tangent function. But in this video, I'm going to work it out using integration by parts. So what I'm going to do is I'm going to break up the x to the third. And I did something like this in another video involving another function, x squared and an x here. I'm going to put the x with the 1 plus x squared, quantity squared. That'll be one function, and the x squared will be another one. So here's the setup that I have then. Here's the formula for integration by parts. Integral of u dv equals to the product of u and v minus the integral of v du. So like I said, breaking up the x to the third into x squared and x. So I'm going to let x squared be the u. That's the part I'm going to compute the derivative of. Du then would be 2x dx. And the dv will be the other part that I took from the x cubed dx, and that's going to be over 1 plus x squared squared. So we're going to take this integral here with respect to v, and this integral here, and I'm going to use a t substitution since I already have the u over here. So let's let t equal to 1 plus x squared. Then dt would equal to, derivative of this will be 2x dx divided by 2, and then this integral will become x dx, and would be dt over 2. This would be dt, and I put the 1/2 out in front, and then there'll be u, or t I should say, in the denominator. T is 1 plus x squared, and then you're squaring that. You get that. And then take this to the numerator, becomes a positive or a negative exponent here, t to the negative 2 dt. Add 1 to the exponent, that's t to the negative 1. And then divide the coefficient by negative 1, this gives me a negative 1/2. And go back to the original variable here. So where the t is, you put in 1 plus x squared, and the negative brings it to the denominator. So that's how we got this part right here. And you got the 1/2. The minus 1/2 here, so this is your v then. So we got all the parts we need then. Just put this together then with the formula. Then go with this then, it's going to be the u times the v. Right there. That's the first part of the answer. So this would be x squared, and you got a minus there. You got a 2, and you got a 1 plus x squared. And then we got a minus this formula here, and then it's the integral of v. So this is v right here. So this would be minus 1 over 2 over 1 plus x squared. And then that's multiplied by du right here. So this is going to be 2x dx. So let me rewrite this way, minus 1/2 then. And this is x squared over 1 plus x squared, or x squared plus 1, either way you want to write it. And then it's plus here, double negative here, and then the 2 cancels here, and this 2 cancels here. And we have the integral then. Got a x left over there, x over 1 plus x squared. And then you got your dx. And now for this integral, notice the derivative of the denominator, 1 plus x squared, is 2x, and you got an x right there. So if I let u, I got to pick another variable here, so if I let w equal to 1 plus x squared, then dw would equal to 2x dx divided by 2 here. Then notice here the x dx is going to become dw over 2, and this will be w, dw over w. That's the thing, is 1 over u du. So that's your natural log. again. So again, rewrite this minus 1/2 x squared over 1 plus x squared. So again, if I plug in the substitutions that I have over here, I would get dw over w, and then I would have the 1/2 out in front here. So that would just give me then 1/2 natural log of absolute value of w in this case. But we don't need the absolute values because 1 plus x squared is always positive. So we get this. So using integration by parts, we get the answer of minus 1/2 parentheses x squared over 1 plus x squared plus 1/2 multiplying the natural log of 1 plus x squared. Now in a subsequent or later video, I'll work out the same problem so you can see the difference using a trig substitution. And you'll see that the two answers don't really match up. Use a different method. But what happens when you do that, you simplify one answer to get the other one, or vice versa. You can show that they're the same answer. And I'll do that in a later video. But for now, this is the answer to this one. Thanks for watching. We'll see you next time.